In this video, I'm going to go over how you calculate average atomic mass. Now, a lot of times this is also just said atomic mass, but I'd like to have the word average in there just because it reminds you that this is a weighted average. So when you do a weighted average, you have to pay attention to the relative abundance of whatever isotopes you're talking about. So in this case, I'm covering silicon. There's three common isotopes of silicon, mass number 28, 29, and 30. And I want to figure out the average atomic mass. And what I have to do is pay attention to the mass of each isotope and the relative abundance. So silicon 28, for example, it has this mass here, 27.9769 atomic mass units, and a relative abundance of 92.23%. Silicon 29, with this mass here, with a relative abundance that's much less. It's a little less than 5%, so 4.67. And then there's silicon 30 that has a relative abundance of only around 3%. So when I look at these percentages, before I even start the problem, over 90% of the silicon that's out there is silicon 28. So when I get my average atomic mass, I should expect the number to be very close to 28, since most of it is that silicon 28. So when you are doing this, one of the things you want to do is be very consistent in how you set it up. So I'm going to start off with silicon 28, the first isotope that was listed in the problem. I want to write down the mass of it, 27.9769, and I'm going to multiply it by the relative abundance, but I have to convert this into a decimal. So remember, that's like dividing by 100. You're moving the decimal point 2 places to the left, so it becomes 0.9223. When you do the math for this, you are multiplying, so you are going by the least number of significant digits. This one has 4, so I'm going to round my answer off to 4 significant digits, 25.80. I'm going to do the same thing for the next two isotopes, silicon 29, and here's the mass, 28.9765, and the relative abundance is 4.67%. Now, this is a spot where I've seen people make mistakes kind of frequently. When you do this, remember 4.67% becomes 0.0467. You need that 0 in there. If you're going too fast, a lot of times what I've seen people put 0.467. When you multiply that out and match the significant digits, you get 1.35. And now you have silicon 30. The mass is 29.9738. Multiply it by the relative abundance, becomes 0.0310. Again, pay attention to how many times you move the decimal point, and that becomes 0.929. Now all you have to do is add up these three numbers. Now when you add, you go by the least number of decimal places. And that has 2, and this one has 3. So we're going to round it off to 2 decimal places. And when you do that, what you get is 28.08, and it's atomic mass units. And what we said from the beginning is that since silicon 28 has a very high relative abundance, we should expect the average atomic mass to be close to 28, and that's what we get. 28.08. So if you set a problem like that, if you're consistent and set it up nice and neat each time, you should be able to do these problems fairly easy.